90% of the students make mistakes in numericals based on concentration terms, even though they know concentration terms properly. Why it is so? I will tell you today in this video. So without any delay, let us start the numericals based on concentration term. So in last few lectures, we discussed about theoretical statements followed by numericals, again theoretical statements followed by numericals. In last lecture, we completed the most important concentration terms, theoretical statements. Today's lecture, we are going to start questions based on concentration terms. See first question. What will be molarity of solution when water is added to? See here we are adding water to the solution. What will be molarity of solution when water is added to 16.4 grams of calcium nitrate, 16.4 grams of calcium nitrate to make 100 ml of solution. So what will be molarity of solution when water is added to 16.4 grams calcium nitrate to make 100 ml of solution? So see here, to make 100 ml of solution. So molarity formula here we know, molarity is equal to number of moles of solute by volume of solution in liters. Molarity is equal to number of moles of solute by volume of solution in liters. So that is 16.4 grams Na calcium nitrate given by 164 is the molecular mass of calcium nitrate. 164 is the molecular mass of calcium nitrate. By volume of solution, how much it is given? 100 ml given. So 100 ml solution, which is equal to 0.1 liters. On overall calculation, you will get 1 molar. You can write capital M or 1 molar. Both are same. And then next question. Calculate molality. Once again, look at the question. Previous question was based on molarity. New question based on molality. Calculate molality of solution containing 20 grams of NaOH. Here NaOH given in 250 grams of water. Here they gave water. Calculate molarity of solution containing 20 grams of NaOH in 250 grams of water. So 250 grams of water given. So according to given information, in 250 grams of water, we need to find how much amount of 20 grams of NaOH is present in 250 grams of water. We need to find molarity of solution. And here we know molality formula. See, major difference between molarity based on number of moles of solute per liter solution, whereas molality based on number of moles of solute per kg solvent. There is difference. There solution, here solvent. So number of moles of solute, how we calculate? Given mass by molecular mass. Molecular mass of NaOH is 40. So 20 by 40 here. 20 by 40. So with this information, 20 by 40 number of moles of solute by weight of solvent kg is 0.25 kg. Overall you are getting 2 small m, that is molal you can write, 2 mole per kg you can write, or small m, 2m. So main difference, see there, volume of solution in molarity, here weight of solvent in kg. Underline the point, solvent weight we use in denominator in molality. Next, moving further to question. How many grams of H2SO4 present in 500 ml of 0.2 molar H2SO4 solution? How many grams of H2SO4 present in 500 ml of 0.2 molar H2SO4 solution? So we need to find here amount of solute now this time. Amount of solute present in 500 ml of 0.2 molar H2SO4 solution. Regular formula I am writing here. Molarity is equal to number of moles of solute by volume of solution in liters. So if you substitute the relation, number of moles of solute, how to find? First, for finding amount of H2SO4, we should know moles. So number of moles, what I wrote here, m into V, giving 0.2 into 500 by 1000, that we are converting into liters, is equal to 0.1 moles. So 0.1 moles we got. Then followed by, once if you know 0.1 moles of H2SO4 present, 1 mole of H2SO4 weigh 98 grams, 0.1 mole of H2SO4 equal to 0.1 into 98. 98 is molar mass of H2SO4. So 0.1 into 98 is equal to 9.8 grams. That is for the mass of solute H2SO4. Next question. Calculate ppm. See, ppm, parts per million, we use only for dilute solutions. That very dilute solutions, we use parts per million concentration term. Calculate ppm of mercury in water. Calculate ppm of mercury in water in a sample containing 30 milligrams of mercury. Calculate ppm of mercury in water in a sample containing 30 milligrams of mercury in 500 ml of solution. In 500 ml of solution. See now, in 500 ml of solution, we need to find, go through question once properly. So number of ppm, that is parts per million, you can write weight of solute by weight of solution. Weight of solute by weight of solution. Remember, here is some, in few books it is given like weight of solute by weight of solvent. Whether you write solution or solvent, you will not get much more difference because very dilute solutions. So weight of solute by weight of solution. Sometimes we take even solvent as solution directly because negligible amount of solute here. So now you see, weight of solute, how we write? 30 milligrams here given, mass of Hg. So 30 milligrams, as it is given in milligrams, we express both in milligrams or you can convert into grams. Both are fine. 30 milligrams and density of H2O given as 1 gram per ml. So mass of mercury is equal to 30 milligrams. But here mass of water we don't know. They gave volume of water. Then how to find? Density given. We know density is equal to mass by volume. Once if you know density as well as volume, easily you can find mass. How? Mass of H2O is equal to volume into density. Volume into density, like mass of H2O is 500 into density how much? It is 1. 500 into 1. So overall you will get here 500 grams. Density into V. So as density is equal to mass by volume. So mass of H2O is equal to density into volume. Density is 1, volume is 500. Overall you will get 500 grams. Once if you know this 500 grams, then what we can do here? Substitute in the formula. Number of ppm is equal to weight of solute, that is 30 milligrams, or number of ppm of mercury is equal to 30 milligrams by 30 milligrams. You can express in grams or milligrams, whatever, both should be in same unit. I am taking milligrams. 30 milligrams by 500 grams. You convert into milligrams, 50 into 10 power 4 milligrams. If you take solvent weight in milligrams, then both should be solute as well as solvent should be milligrams, then into 10 power 6. 60 ppm should be the answer here. See, solvent almost are equal to solution. So that's why in ppm, if solution information given, directly you can use in. If solvent information given, directly you can use in denominator. No much more difference. Next question. So here important point is parts per million expressing or concentration expressing term mainly used for dilute solutions, very dilute solutions. Chance of confusion, in denominator I wrote solution. Few books it is given as solvent, but any one you can take. Find molarity of aqueous solution of CH3COOH. Find molarity of aqueous solution of CH3COOH whose molarity is 2 molar, whose molarity is 2 molar and density is 1.2 gram per ml. Find molality of aqueous solution of CH3COOH whose molarity is 2 molar and density is equal to 1.2 gram per ml. So here both the lines, properly monitor it. Interconversion hint, whatever we discussed in last class I am writing as hint. Molality is equal to 1000 into molarity by 1000 into density of solution minus molarity into molecular weight of solute. Molecular weight of solute. Interconversion formula. Substitute all those required terms. 1000 into molarity, 1000 into density 1.2 minus molarity 2 into molecular weight of solute. CH3COOH given in the question. CH3COOH molecular weight, that is 60. It is given in the question. I am writing here. CH3COOH molecular weight is equal to 60. 60 here overall. So after calculation, calculate everyone. 1000 into 2 by 1000 into 1.2 minus 2 into 60, 1.85 molal. Small m, that is molality information. 1.85 molal. See this step, the interconversion, an important question it is. Important question model. Next question. A solution has 80% weight by weight NaOH. A solution has 80% W by W NaOH with density 2 gram per liter. With density 2 gram per liter, find molarity and then molality. Both the terms asked, molarity and molality of solution. They asked both here. See how to find now. 80% W by W NaOH with density 2 gram per liter. Find molarity and then molality of solution. See, before going for solution, every time you monitor, observe the question, pause the video, try to do from your side, get the answer, then match with the explanation, whatever we are doing here. Let volume of solution be V. Let volume of solution be V liter, because one thing specified about volume of solution. If volume of solution is V liter, volume of solution be V liter, then mass of solute is equal to, see how we calculate mass. Density is equal to mass by volume. Then mass of solute is equal to density into volume. Mass of solute is equal to density into volume. A kind of formula. Density is equal to mass by volume. So mass of solute is equal to density into volume. So then Once if you know this method, density into volume, then what we need to do? Think how we need to proceed further for this. Our target is to find molarity first. No other information given. Mass of solute, that is they gave in terms of 80% W by W. So what I am doing now, mass of solute is equal to density into volume. I think it is clear to everyone. But how much they mentioned? They mentioned only 80% out of 100. D into V you can write if it is 100%. But here mass of solute is equal to D into V. If it is 80%, what we need to do? D into V we have to multiply with 80. 80 by 100 here. Once again see clearly, if it is 100% directly we can write D into V, but here only 80%. Then what we do? Then we multiply with 80% here given. So 2 into volume is V into 80 by 100. As weight by weight is 80%, we multiplied with 80. 80%. So now, whatever value we are getting, that is 1.6 V, that is mass of solute. 1.6 V is mass of solute. So molarity is equal to number of moles of solute. How we write? Weight of solute by molar mass. Weight of solute is 1.6 V. 1.6 V. So 1.6 V by 40, that is molar mass of NaOH by volume of solution in liters. Let it be V. Already we assumed. Answer is 0.04 molarity. That is capital M, molarity. Now, whatever we wrote 1.6 V by 40, that is number of moles of solute, remember. Next. Second question, molality we need to calculate. Molality. So, how we need to calculate here molality? Molality M is equal to formula weight of solute, number of moles of solute by weight of solvent in kg. First I am writing 1.6 V by 40, that is as usual number of moles of solute. By here why I wrote 1000, see directly I wrote 1000 here because volume here 2V minus 1.6 V, solution minus solute, difference we calculated, we need in per kg, that's why solution minus solute, difference we got solvent, you will get in 100 m, 100 molal, overall final answer 2V minus 1.6 V is equal to 100 m molal. Observe both the expressions. Take a pause and observe both the expressions. Next question. See molarity, most important terms. If there is confusion between these two terms, difficult to solve upcoming questions, even these questions. Okay, next proceed further. 80 grams NaOH was added to 2 liter H2O. 80 grams of NaOH was added to 2 liter H2O. Find molality. Find molality of solution. Find molality of solution if density of water is 1 gram per ml. Here density of water is 1 gram per ml. 80 grams NaOH was added to 2 liters H2O. Find molarity of solution if density of water is 1 gram per ml. So how we need to proceed with this? See here. We know molality formula. Molarity is equal to How much you will get? Molarity is equal to 80 by 40 because 80 grams of NaOH given. 40 is here NaOH molar mass. 80 by 40 by overall here weight of solvent we need here. Weight of solvent, but here see what they gave. Solvent volume given, density given. As usual, same method. Density into volume. Density into volume. That gives weight of solvent. Density into volume. So overall here we got 1 molal. The answer for the given question, that is 1 molal. 1 molal solution. Next question. See how they asked many number of questions. Similar patterns asked in JEE Mains. Find final molarity. Here the pattern you see, when two solutions having same solute are mixed. When two solutions having same solute are mixed, to find molarity of resultant solution, we have to use the method. Before that, you see question what I wrote here. Find final molarity in the given example. 500 ml 0.1 molar HCl mixed with 500 ml 0.2 molar HCl. Both are mixed. 500 ml 0.1 molar HCl and 500 ml 0.2 molar HCl. So how we need to find here? See. For that, MTVT is equal to M total V total is equal to M1 V1 plus M2 V2. For finding final molarity, we use this. So M1 V1, that is total volume is 1000 because 500 plus 500. Total molarity we need to find. Initial molarity 0.1. 0.1 into volume 500. Initial final molarity 0.2 means second solution. First solution molarity is 0.1, second solution molarity is 0.2. Final molarity we need to find M total is equal to 0.15 molar. Overall after calculation you will get 0.15 molar, that is final solution. The question format based on mixing of two solutions where solution having same type of solute. One more question format. See here question now. How much H2O? How much H2O should be added? How much H2O should be added to 2 molar HCl? How much H2O should be added to 2 molar HCl solution? 2 molar HCl solution to form 1 liter of 0.5 molar HCl. How much H2O should be added to 2 molar HCl solution to form 1 liter of 0.5 molar HCl solution? See now, again let us take assumption. Let initial volume be V. Initial volume be V here. Some amount of water we are adding to this. How much amount of water added we need to find here. It's a dilution formula. M1 V1 is equal to M2 V2. Whenever solution is diluted, we have to use it. So here 2 into V1. V1 is V, initial volume. M2 is 0.5. Volume it is 1 liter. So after calculation here V value is 0.25. Here students make mistakes. Here volume whatever we got, it's not answer. It is initial volume. They are asking how much amount of water should be added. So to get amount of water added, just you have to take change in volume. Or final volume minus initial volume if we take, resultant is the amount of water we added. Final volume is 1 liter. Initial volume 0.25. Overall 0.75 liters is the amount of water what we added here. To get resultant 1 liter of 0.5 molar HCl solution. So two different question formats we studied. When two solutions of same solute mixed, when same solution diluted. To find new molarity or to find volume of water added, we have to use this question format. Similar question format which they asked in JEE Mains. See here. What volume of, or you can say what volumes of 1 molar and 2 molar H2SO4, 1 molar and 2 molar H2SO4 solution are required, what volumes of 1 molar and 2 molar H2SO4 solution are required to produce 2 liters of 1.75 molar H2SO4 solution. 1.75 molar H2SO4 solution. What volumes of 1 molar and 2 molar H2SO4 solution are required to produce 2 liters of 1.75 molar H2SO4 solution? So here what we need to do, see, let x liters be volume of 1 molar solution. See, total is 2 liter, out of which x liters be volume of 1 molar solution. It is mixture given. If x liter is 1 molar solution, 2 minus x liter is volume of 2 molar solution. 2 molar solution. So now how to find overall what volumes of are required to produce 2 liter they prepared by mixing these two. First, if we calculate final moles, whatever they get 2 liters 1.75 given, moles of H2SO4, how you will get? Volume into molarity. So volume 2 liter, molarity 1.75. If we combine these two, see how we calculate moles? Molarity into volume. Total molarity 1.75, total volume 2 liters. So indirectly what we are applying here? MTVT is equal to M1V1 plus M2V2. MTVT is equal to M1V1 plus M2V2. Here the formula what we are applying in this case. So number of moles is equal to 1 into x plus 2 minus x into 2. So after calculation, here you will get x value first. See, moles of H2SO4 we wrote, that is nothing but M total into V total. M total, V total here in this case. So then after calculation x value you see here is equal to 0.5 liters. That is 1 molar H2SO4 solution. 0.5 liters of 1 molar H2SO4 solution here given. And then out of 2 liters 0.5 is 1 molar, remaining 1.5 liters is 2 molar H2SO4 solution. 2 molar H2SO4 solution. So both are required in given proportionate amounts. 0.5 liters of 1 molar, 1.5 liters of 2 molar H2SO4 solution are required. Important question asked in JEE Mains. Very important question. Next, once refer the solution. Very important question model. Refer the solution. And next, after completion of this question, next we are going to see one more question that is based on mole fraction. Based on mole fraction, how we do? See here. Here they gave one information. See the question now. Based on mole fraction. Easy, based on mole fraction. See, a gaseous mixture contains 2 moles of N2 and 7 moles of O2. They are asking here find the mole fraction of, or you can say find their mole fractions. So how we find mole fractions? We know formula. Mole fraction is equal to number of moles of given component, that is number of moles of N2 by total moles. Total moles how we write? Total moles here we write by using number of moles of N2 plus number of moles of O2. N2 by number of moles of N2 plus number of moles of O2, total moles. So I can do calculation here, 2 by 2 plus 7, which is 2 by 9. So 2 by 9 value, if we calculate approximately, that is 2 by 9. So it is 0.2 by 9, 0.22. So that is 0.22. Here we know one important relation. Sum of mole fractions of all the components in a given mixture is equal to 1. So mole fraction of N2 plus mole fraction of O2 is equal to 1. If you know mole fraction of N2, then mole fraction of O2, how we can calculate? 1 minus 0.22. So in such cases, mole fraction of O2 is equal to 0.78. 0.78. So that is about some important question models based on concentration terms. See, first we are discussing about JEE Mains question format questions. At last, after completion of entire series, advanced questions exercise video lecture you are going to see at last. Okay, meanwhile, I hope everyone got clarity about the question formats, how we need to solve based on concentration terms. These questions will be continued with advanced exercise at last. Until then, once again, refer those previous lectures. Be ready for upcoming lectures. Thank you. Thank you for your patient listening.